We work to develop creative thinking skills, unique innovation, and critical thinking among students. We are committed to enhance the employability quotient of the student with holistic development. Toward this objective, we have dedicated special interest groups on emerging technologies. Apart from this, we have 23 clubs for extracurricular activities, games, and sports. The various SIG focus on the capacity building of the faculty and students and enable them to take up the activities related to training, research, and development in the emerging field. Code of competence and emphasis on quality at the level right from the institute can be where we provide organic vegetables fresh grown in our agriculture fields under Green Wave clubs. To classroom teaching by adopting best practices is our prime motto. Behind these innovative ideas is our Honorable Director General IST IIP IMA Shri Arvind Bhatnagar Sir, IRS ex-Principal Commissioner. It's my honor to introduce Sir. Sir is a senior bureaucrat with overall experience of 44 years with Income Tax Department, Academia and Private Sector. Held the post of Additional Director General of National Academy of Direct Taxes, Apex Training Institute for imparting training to IRS provisional as well as senior bureaucrats. Coordinated international engagements with foreign university and government, also managed various international courses and infrastructure of the academy. Completed certificate courses from UK University and University of Maryland, USA, as well as Executive MBA from IIM Bangalore. Superseded the 1983 batch based on the outstanding performance and also received the prestigious award for best practices instituted by the department from Honorable Minister of State Finance. Recently, Sir received a Captains of the Industry Award for MP Leading Business Visionaries. Sir also worked in Ron Deputation and also pioneer of digitization of IT return department. Post he took the command of IST as a Director General. IST witnessed a spectacular escalation in the admission to the Faculty of Engineering by 400%, while admission in the management stream increased threefold. May I request DG Sir to set up the tone of today's webinar. Sir, please. Sir, please.
Am I audible?
Yes, sir.
Okay. That a very eminent professor, Dr. Bui Han from Vietnam, Director of Data Analytics and Artificial Intelligence Lab, Director of Masters of Information System Program, is with us. I welcome you, sir. And it is so nice of you that you have accepted our invitation and given us your valuable time. The topic which you have selected, it is not of my domain, but somehow, yes, it is. Because I am also a student of management. So that part, apart from the technical thing, how we can use this sentiment analysis as a management expert or as a senior executive, that is very interesting. I was going through the various descriptions of sentiment analysis, and very interesting things I have noticed. Let me not visit what is sentiment analysis when expert like you sitting before us. But from management point of view, sentiment analysis, which you are using as a machine learning technique, that detects polarity, positive or negative opinion within text. So what is the use of that? I will not go through this whole thing because sentimental analysis is more of understanding people's emotion, which is very essential for businesses. Since customers are able to express their thoughts and feelings more openly than ever before. And with the help of machine learning tools, it will be very easy for us to analyze the customer feedback. From survey responses to social media conversations, brands are able to listen attentively to their customers and tailor products and services to meet their needs. So more or less, there are, from my point of view, there are 5 applications. The first one is social media monitoring. I remember that in 9th April 2017, United Airlines forcibly removed a passenger from an overbooked flight. This nightmarish incident was somehow filmed by other passengers on their smartphones and posted immediately. One of the videos posted to Facebook was shared more than 87,000 times and viewed 6.8 million videos posted to Facebook, 6.8 million times by 6 p.m. on Monday, just 24 hours later. You see the publicity. 87 times it was shared and 6.8 million times by 6 p.m. within 24 hours. So this fiasco was magnified horrifically by the company's dismissive response. On Monday afternoon, United Airlines tweeted a statement from the CEO apologizing for having to re-accommodate customers. Cue public outrage, you can imagine the field day on Twitter. So this is exactly the kind of PR catastrophe you can avoid with sentiment analysis. It is also an excellent example of why it is important to care not only about if people are talking about your brand, but how they are talking about it. More mentions don't equal positive mentions. In today's day and age, brands of all shapes and sizes have meaningful interaction with customers, leads, and even competition on social networks like Facebook, Twitter, Instagram. Interestingly, I would like to the professor that we are using also social media platform very effectively. Most marketing departments are already tuned into online mentions. As far as volume, they measure more chatter as more brand awareness. Nowadays, our businesses need to look for deeper insights. By using sentiment analysis on social media, one can get incredible insights into the quality of conversation that is happening around a brand. So in short, sentiment analysis can be used to analyze tweets and or Facebook posts over a period of time to detect sentiment of a particular audience. Monitor social media mentions of your brand and automatically categorize by agenda. Automatically route social media mentions to team members best fit to respond. Automate any or all of these processes can gain deep insight into what is happening across your social media channels. So there are top benefits of social media monitoring. I will not go in detail, but these are the top benefits for social media monitoring. Next benefit is brand monitoring. Not only do brands have a wealth of information available on social media, but also across the internet. Instead of focusing on a specific social media, platforms such as Facebook and Twitter, we can find mentions in places like news, blogs, and forums again. Looking at not just the volume of mentions, but also the quality of those mentions. In our earlier example of United Airlines, for instance, the flare-up started on the social media platforms of a few passengers. Within hours, it was picked up by news sites and spread like wildfire fire across the US. News then spread to China and Vietnam as the passenger was reported to be an American of Chinese Vietnamese descent. And people accused the perpetrator of racial profiling. Sorry. In China, the incident became the #1 trending topic on Weibo, a microblogging site with almost 500 million users. Recently, President Trump has made one remark regarding the blacks when there was an incident of violence. And within few hours, there was a reaction all over the world. And again, this is all happening within mere hours and days of when the incident took place. So this is the importance of this sentiment analysis. Next is we can see can be used to analyze news articles, blog posts, forum discussions, and other text on the internet over a period of time to sentiment of a particular audience. I'm very happy that both the principals are sitting. I think all the three principals are sitting. Principal of IST, principal of IMR. So let the principal of IST should work also on this sentiment analysis, and let the principal of IMR should use. Automatically categorize the urgency of online mentions of your brand. Automatically alert designated team members of online mentions that concern their area of work. So all these things are going on regarding brand monitoring. One major use is also customer feedback. Feedback is the most important thing in today's world. On the other day when I was talking about digital pedagogy, now we are talking about recursive feedback. Feedback is very important to get ourselves prepared in a better way, even during the process. So this is also one of the very good benefits of customer feedback. The social media and brand monitoring offer us immediate, unfiltered, invaluable information on customer sentiment. However, there are two other troves of insight: surveys and customer support interactions. One is called NPS, Net Promoter Score. Surveys are one of the most popular ways for business to gain feedback and start by asking a simple question. Would you recommend this company, product, or service to a friend or family member? This results in a simple number or score. Businesses use this score to identify customer as promoter, passives or detractors. The goal is to identify overall customer experience and find ways to elevate all customers to promoter level, whether they theoretically will buy more, stay longer, and refer other customers. That is what I am saying to my faculty, that you have to take care of your customer, and your customers are your students. How they are behaving, and you have to take care of each customer separately. That is why differentiated learning or personalized learning or adaptive learning is most important in today's world. Particularly, all the faculty members must understand, if they will not take care of the personal or adaptive learning or differentiated learning, things will never work. Now you have to customize your lectures as per the need of the students. You have to evaluate their strengths and weaknesses, and accordingly you should plan your affairs. Actually, this is also very interesting. We all know the drill. Stellar customer experiences mean a high rate of returning customers. Leading companies know that how they deliver is just as, if not more, important as what they deliver. Customers expect their experiences with companies to be immediate, intuitive, personal, and hassle-free. In fact, research shows that 25% of customers will switch to a competitor after just one negative interaction. Let me remind you very specifically, today's word is customer's word. Nowadays, I'm seeing my daughter, she's here from US, and now the way she's giving order, the way that she's returning back, they will never say, why? Yes, ma'am. Yes, that's the only answer. Because they are more bothered about their reaction. Next is, so this is lots of advantages. Rapidly detect disgruntled customers and surface their tickets to the top. Route queries to specific team members best suited to respond. Gain deep insight into what is happening across your customer support. So this is becoming a huge area, and I'm very happy, and I must compliment Prashant Richarya ji, Puneet ji, and the whole CS department and IT department to initiate and requested Professor to give his lecture on this topic. And I'm very happy that Principal IMR is also sitting here. Next is, I will not take much of your time. Other things are common mostly. That is like market research, as we have already seen. Sentiment analysis empowers all kinds of market research and competitive analysis. Whether you are exploring a new market, anticipating future trends, or having an edge over the competition, sentimental analysis can make all the difference. And lots of things are there. Analyze product review of your brand, compare those with the competition, generate weekly, monthly, or daily report, a sort of early warning system, compare sentiments across international markets, analyze formal market reports of Business Journal for long-term and broader trends, analyze tweets and social media posts for real-time happening, analyze reviews for unfiltered customer feedback. So these are the few advantages which is for us, for the people who are managing businesses or any institutions, because they should be aware what is happening around. So again, I welcome you, sir, here in IST, IIP, and IMR family. And I'm again thankful to you that you have given your valuable time to us. Thank you very much.
Thank you, sir. For this international webinar, I again welcome you all. Honorable Chief Guest, Director General, IST IIP IMR, Shri Arvind Bhatnagar, sir. Honorable Principal, IST Dr. Keshav Patidar, sir. Honorable Principal, IIP Dr. Dinesh Mishra, sir. Honorable Principal, IIMR Dr. Simajit Kaur, ma'am. Honorable HOD, Computer Science and Engineering Department, Mr. Puneet Duggal, sir. Keynote Speaker of the Day, Dr. Guitham Hung, and all the dignitaries, faculty members, and participants. With great opportunity, I present to you and Dr. Guitham Hung is a Director of Data Analytics and Artificial Intelligence Laboratory, as well as Director of the Master Undergraduate Information System. Information System Program of Engineering Technology, Faculty to North University. My request to you, sir, please throw light on today's topic, sentiment analysis from machine learning to deep learning approach. Over to you, sir. Sir, please.
Okay. Good afternoon, everyone. I'm happy to join this conference organized by Department of Computer Science and Engineering in the Institute of Science and Technology, India. Today, my topic is sentiment analysis from machine learning to deep learning approach. My name is Bùi Thanh Hong. I'm from Director Data Analysis and Artificial Intelligence Laboratory, Engineering Technology Faculty, Kusamoth University. Here is an outline of my presentation. First, I will talk about the introduction. Next is about the sentiment analysis. After that, I will talk about the machine learning and deep learning and some experiment from my research. And lastly, I will give conclusion. Now, let's begin with the part one, introduction. As you know, sentiment analysis is one field of natural language processing. The first question is, what is natural language processing? You know that natural language processing is the process information contained in the natural language text, and this is known as computational linguistics, human language technology, or natural language engineering. And natural language processing is one method of artificial intelligence, and there are a lot of natural language processing tasks. Here you can see that here some related to linguistics, and another is some application, for example, information retrieval, name entity recognition, sentiment analysis, uh, yes, machine translation, natural language generation, question answering system, dialogue system. There are a lot of tasks in natural language processing. And what is the sentiment analysis? Yeah, Professor just talked about sentiment analysis, so that I will start time in the sentiment analysis. Uh, Today, social network is affect to our life, and there are a lot of social network, YouTube, Facebook, Twitter, yes. And for example, if you search in the Google product search, you can see that the picture of it, you can see that the comment for a picture of, for example, here's the camera. And if you know about the opinion of other customer, you can choose which camera is suitable to you. And this means that the sentiment analysis is not is interesting, not in uh, research as well as in business. For example, here is in America election 4 years ago. It's the candidate present know about the opinion of the population. He can give the vote strategy for his election. And by command 1992, he divided the sentiment to six degrees: anger, sadness, happiness, fear, and surprise. And by the Martini 2014, he divided to the 22 compound facial expression of emotion. And what is the sentiment analysis? Sentiment analysis or opinion mining is a computational study of opinion, sentiment appraisal, evaluation, and emotion. And sentiment analysis is very important because opinion are key influence of our behavior and the role of AI and chatbot, and so that emotion and sentiment are key to human communication. The problem is very fascinating, uh, and it's a major technology from the LNP, but it's hard. Researcher has mainly studied sentiment analysis at three level: document level, sentence level, and aspect level. Uh, what is the document level? Document level means that this classify an opinionated document as expressing an overall positive or negative opinion. And in the sentence level, this classify individual sentence in a document. And the aspect level, check and summarize people opinion and express on entity and expect picture of entities. And here is a roadmap of sentiment analysis: spams detection, sentiment retrieval, sentiment extraction, sentiment classification, sentiment summarization, and sentiment rating. How about the publication? We had two famous publications. The first in the Springer. It When I checked the keyword in sentiment analysis in this time, I got a lot of publication in article, conference paper, yes. And with the keyword opinion mining in 2019 to 2020, with this publication. How about in the Science Direct? Science Direct, it's the when I find the keyword sentiment analysis in 2019, I got 4,303 results. And about the opinion mining in this year with this result. This means that the sentiment analysis is popular public for researchers. By the Russell to 1980, to know how about the sentiment analysis, he divides the sentence to work and present the work in the figure and in the space here, and from space we can know that the sentence is negative or positive based on the work in the space. And there are many approaches for sentiment analysis. However, we have only two main approaches. The first is by lexical based, and the second is the machine learning. Here is by lexical based, and the second is the machine learning. And you can see the figure here. The lexical and Rohn and supply is very famous in this time, and is a stem with the supervised learning and deep learning model from the 2011. Now, you know about the sentiment analysis and how to approach for sentiment analysis problem. And now I will talk about the machine learning approach for sentiment analysis. You know that the machine learning approach is the main approach for artificial intelligence problem, and the deep learning is the main approach in the machine learning. This was born in 2010, and machine learning is 1980. Here is a history of machine learning. Yes, you can see that there are about the history of machine learning. Yes. And the application of machine learning with a lot of application we use in our life, Spotify, Amazon, email, Facebook, yes, self-driving car, yes. And what is machine learning? By the term Mikhail, he defined that a computer program is said to learn from experiment E with respect to some class of task T and performance measure P. It is performance at task in T as measured by P, improved with the experiment E. Is defined about the machine learning by the term Mikhail. For example, flying checker. T, what is the T? T means that the start of flying checker, and E, the experiment of playing many game of checker, and P means that the probability that program win the next game. Another example is we recognize the cat, and now in this example, T means that the start of identified cat in the picture, and E means that the experiment of looking at a lot of cat picture, and P means that the probability that the program will detect a cat in the picture. And we divide machine learning into three main fields. The first is unsupervised learning. The second is the supervised learning, and the last is reinforcement learning. How the machine learning work? You can see that machine learning work based on our data, and from our data we will analyze data, find the pattern, and use machine learning technique to predict our decision. And in the past time, many researchers focus on how to use machine learning for sentiment analysis, and They use the linguistic integrating with the machine learning algorithm for the linguistic dependency parsing is famous in the linguistic dependency parsing. We have the raw sentence and we have the post-duck sentence, and from that we can make the word dependency sentence. Here is another dependency tree. You can see that. Yes. And another is the parsing. It means that in a definitive grammar, from the grammar, for example, here's the rule, and we can build the tree from this rule. And another is the semantic analysis. If we show a problem sentiment analysis by linguistic, the semantic analysis is one main approach. And backup work, what is the backup work one on hop vector? On hop vector. Here we have some sentence. From the sentence, we can build the dictionary or backup work. And from the backup work here, we can make the one hop vector. For example, we have this sentence, and we have the backup work is a 10 work. And for some 10 work, we can see that this in the position 6, and this is 1. Yes. And we can build the one hop vector from the backup work. And what is n-gram? N-gram is the connecting string of n. For example, here with the n equals 1, we have the 1 gram. This is a sentence. And with the 2 gram, we have this is a sentence. And with the 3 gram, is yes. And in the machine learning, the GF IDF here wants the more picture for the sentiment analysis. And what is GF IDF? GF IDF means that it's a stand for term frequency invert document frequency. GF means that term frequency, and IDF means that inverse document frequency. And we can calculate IDF and GF IDF by this formula. And here's the example how to show machine learning, how to use machine learning for the sentiment analysis. For example, we have the data. We will use the pre-process tokenize, build vocabulary, transform to vector, and calculate GF IDF term weighting. Here is the corpus. And we get the vocabulary and corpus after transformer. And we calculate the GF IDF picture. And from that, we use the machine learning for classifying. In this example, we only classify the sentence to the two class, negative or positive. And we use a support vector machine. This machine learning technique is a very famous machine learning technique with the high dimension, memory efficient, and versatility. How SVM work? You can see that SVM means that we will find the hyperlink with the minimum state between divide the two class separately. And how SVM work? You can see that here, and you can get. And if we had more two class, and how SVM works is we had more class. Here example we have 3 class, and first we divide the first to remain class, and from the result we will define with the class for. We can define the class by the accuracy we get here. And in the SVM, it means that we will show this equation. And from the equation, we will find the minimi margin. It means that we will find the W and B parameter from this equation. And we can solve quadratic program solver by this equation. And if we use CV or PT, you can solve this equation. Here is step by step how to solve this equation. First, we build P, and next we create T, build G, build H, build A, build B, and find lambda. And from that, apply lambda equal to the formula equation. We can get the W and B. From W and B, we can know the sign of this equation. This is the negative positive. It means that class 1 and the other is the class 0. And we have a lot of machine learning algorithm. Here is the top 10 algorithm for every machine learning engineer should know. Naive Bayes, K-mean, SVM, a priori, linear regression. Yes, you can check that there are a lot of machine learning algorithm. And I just saw the case study about how to use SVM to show the sentiment analysis using sentiment analysis. And now we talk about the deep learning. How deep learning shows the sentiment analysis problem. You know that about the biological neuron. Here is a biological neuron. And we build the artificial neural network, ANN, simulation from the biological neuron. Yes. And in the ANN, backpropagation is one important process. Backpropagation is means that is processing to update the weight by this formula. And from the we can change the artificial neural network to get the good result. And come back to the slide I talked before. Deep learning is one main topic of the one main approach of machine learning, and it was born in 2010. And here is the machine learning, and here is the deep learning. Now you can know what is different between the machine learning and deep learning. Deep learning, machine learning means that we extract the picture and classify. However, deep learning, we can extract picture and classify in the same. And deep learning is very different with the machine learning. For example, in the data, it's big data, and machine learning is small data set. It's a hardware requirement with GPU. Here is the low-end machine. For engineering peculiarity, we need to understand the basic functionality of the data. And here, we have know the picture and how they represent the data. In the changing time, in the deep learning with a long time, and machine learning with a short time. A process time, a few hours of week, and here a few seconds or hour. And number of algorithms is a few, and here is many. How about the data interpretation? It's very difficult to data interpretation. And how about in the machine learning? Some machine learning algorithms are easy to interpret, and the other very hard. And deep learning is proposed by Zri Arthur here, and Zri Arthur here got the Turing Award in 2019. This look like the Nobel Award for the computer science, and they published the deep learning before the 2015. However, in the Nature, they published the deep learning in the Nature in 2015, and I checked in the 7 this month with this citation. What is deep learning? There are many models for the deep learning. For example, FNN, CNN, INN, deep reinforcement learning, or deep unsupervised learning. Here is the symbol of FNN. FNN means that we have the symbol of artificial neural network. How about the recurrent neural network? Recurrent neural network here is the one item in the recurrent neural network. By this formula, we can remember recurrent neural network means that we can remember or forget the picture or the result in the last step or the next step. However, recurrent neural network is only one gate. How for a long process is more difficult if we have reverse bond. It's proposed by Hofstadter et al. In 1997 by modify the recurrent neural network with the four gate FT, IT, CT, and OT. And by the four gates here, we can remember and remember or forget the picture or the picture or the result of the last step or the next step in the long process. If we zoom in more detail in this gate FT, you see that FT is made from the previous layer, previous state, and the picture with the bias. Yeah, another gate is the same. Yes. And bidirectional LSTM, this proposed by Wang et al. 2015. This means that we had two long short-term matter with forward and backward. And combining a forward and backward LSTM, we had the bidirectional LSTM. How about the convolutional neural network? This model proposed by Kushima in 1980 and improved by Likun et al. In 1998. CNN has three main layers: convolution, mach-pooling, and fully connected. Here is the convolution example. We have the picture, and it means that we have the magic with the 99, and with the magic 99, with the kernel here, we can get the small picture 77. We can here is the kernel 33 by manipulation between the original picture with the kernel 3, next 3, and we can reduce the original picture to smaller. Here is 7 and 7, and smaller picture keeps the main picture of the original picture. That's the convolution layer. And the next layer is the pooling. Pooling means that we use the kernel, we have kernel, and here we use the kernel with the 2. And there are many pooling. For example, every pooling or mach-pooling. In this example, we use the mach-pooling. Mach-pooling is the maximum number in the kernel. Yes, the maximum is 1. Maximum is yes, the maximum, and the last the maximum is this number. And with the pooling, we can reduce the picture, the size of picture for the next step. And about the ReLU means that we can omit the overfitting. There are many ways to avoid overfitting, and ReLU one approach. ReLU means that we will change the number in the negative to 0. It's only change the negative number to the 0. For example, here 0. Yes. And the last layer is fully connected. fully connected means that we will flatten the last magic to the one column, yes. And there are many models for the convolution neural network. You can see that here is a LANet, AlexNet, GA, VCC, GoogleNet, or ResNet. And almost the model here is got the high result in the ILSVRC contest. This contest stopped in 2015. And how to apply CNN model on the text? You can see here how to apply CNN model on the text. And another approach is combining CNN and LSTM. CNN can extract the spatial picture, and LSTM work well in classify the class, and that's why we combine CNN and LSTM. And reinforcement learning is reinforcement learning. You know about the reinforcement learning behind the eigen, environment, and action and state here. And how about the deep reinforcement learning? Deep reinforcement learning developed from the reinforcement learning, and you can see that what is different between the deep reinforcement learning with reinforcement learning. It means that we use neural network in this. And in the deep learning, one famous thinker is the attention mechanic. This proposed by Badano et al. 2014. And another famous model is a transform model. It's proposed by Vaswani et al. 2017. Transform model is attention with the encoder and decoder. One main topic, one approach in the deep learning is the deep unsupervised learning. Here I only introduce about some deep unsupervised learning. For example, very directional autoencoder or graph convolution neural network is one main approach in the deep unsupervised learning. Another is a generative adversarial network, GAN. Data proposed by Goodfellow et al. 2014. GAN is a discriminator and generator network. It's the machine learning. We use the most picture is the linguistic with the TF IDF picture. However, in the deep learning, we can use the TF IDF. However, the most famous picture is the work embedding. That's why I will present about the work embedding. Work embedding means that we know about the relation between the work in the context. For example, we know that the king is a man and queen means that woman. Yes. The first author proposed about the work embedding is Thomas Mikloved et al. 2013. They propose two kinds of work embedding, SIBO and SkipRAM. SIBO means that this model predicts from the present context based in the last covered column with a sliding window. Yes. And here's a more detail about the SIBO. We had one hot vector of this work, and from one hot vector, if we use the magic, we can get the vector of this work, and we calculate average of the picture here, the vector here, and with the one hot vector of y, we can use this step many times to get the bad result, and from that we can get the work embedding. Another work embedding proposed by Thomas Mikloved et al. Is the SkipRAM. SkipRAM is opposite with the SIBO. This model predicts the context of a given target work select copper column with a sliding window. And another work embedding technical is the Glovo, provided by Stanford L&T Research. Uh, for the first work embedding simple and steep program, when I checked in the 15 July this year with this citation, yeah, Glovo with citation, and Fatek from the Facebook AI research with the citation, because they give the two papers so that I count the one paper separately. And the last is about is a proposed by work Google AI 2018 with the huge number of citation. Yes, here's more detail. Yes, SIBO with the citation, Galapagos with citation, and the bird with the citation. Yes. And now I talk more about the bird. Bird means that you make the transformer, and you know that transform model. You know that about transform model was born in 2018. That's why work bird was born in 2018. Uh, but make the transformer and attention mechanics that learn contextual relation between work sub work in attack. And the transformer includes two separate mechanics, an encoder and the decoder. Here is a figure describe about the bird. Yes. Now we come back to the sentiment analysis. How to use the deep learning for sentiment analysis. In the beginning of my presentation, I said that there are three levels: document level, sentence level, and aspect level. And it's the document level. You see that there are a lot of application use deep learning approach for sentiment analysis. And the technique here is you work embedding the model here. Yes. And use the attention mechanic or not. With the sentence level, with a lot of application, a lot of researcher use deep learning to show sentiment analysis by the sentence level. And in the aspect level, it's the same. There are a lot of applications using the deep learning approach. And now we know how to use the machine learning or deep learning to solve the sentiment analysis problem. And the next part, I will give you some experiment from my research. The first is I use a machine learning approach for the sentiment analysis. Now take a look about the data set I have. Yeah, here is the data set with the 25,000 sentence, and I apply for the sentence level. Yes. And in setting. Yes. Here the original sentence, which is say that there are a lot of And we use TF IDF in this example. We use the TF-IDF and SVM for classify, SVM for classify. And we get the result here. You can see that the result here, the result. 0 or 72 accuracy. Yes. As the first experiment about how to use machine learning for sentiment analysis. And the second, I will show you about our research published in Frontier in Intelligent Computing Theory and Application book in this year. And I got the best paper award for this conference. In this research, we apply the deep learning method with the four model, CNN, LSTM, CNN, LSTM, and BiLSTM. We apply with different work representation, domain specific and general purpose work embedding into deep learning. And here is the figure describe about our methods. From the data, we apply for Vietnamese language with the pre-processing, with tokenized and not tokenized, with the two work embedding technique, domain specific, and another is the fast text from Facebook AI research. And we apply with the CNN and CNN LSTM. Here's the data we got we collect data from the Footy.pm with the 50,000 comments. And more detail about your data set, our data set by the tokenized and use the Vietnamese stock work by Levin Duyệt. And we do experiment in for approach, and we apply in for deep learning model. And total we got 16 model. We use Keras and TensorFlow framework. And the parameter model we use in the CNN, LSTM, and BiLSTM. And we see that the most fastest is the CNN with the time for each airport here, and the longest is the BiLSTM. The second fast time is the CNN LSTM. And we evaluate by accuracy, calculate by this formula. And we get the result here. From the result, we can get the best result in each approach. Here is the domain specific, and here is general specific with the not tokenized or tokenized. Yes. And we get best result in each approach. And I will make a small demo, and you can see here. Wait a minute. We make a website to run a demo. Yes, we use TensorFlow for backend. And program by the Python language. Yes. Yes, some function is redundant. Yes. Just wait a little. Come back to how to apply. Yeah. data pre-processing, tokenized and not tokenized, with the two work embedding technical, domain specific and fast tech, and apply for deep learning model, LSTM by LSTM, CNN LSTM. Yes, great. Okay, now we load the CNN, LSTM, and by LSTM. And after loading the more form model here, we make the web demo. Yes, wait a minute. And we apply for the Vietnamese language. Yes, we the data analysis. Yes, you can see that the data analysis, and if we analyze the form model here, you can see what is the bad model. Yeah, here the accuracy for the convolution neural network. And we make the small demo, for example. Related, I give the sentence here. The restaurant is not good. And I choose the cement. What? Yes. And it use another upward, for example, cement LSTM. Yes. And I got the result here. It's a small demo, and you can see it how we use the deep learning approach for sentiment analysis. And if you see that here, yes, it's run is okay. Just a small demo how we use the machine learning and deep learning for sentiment analysis. Now let's talk about the experiment. In sentiment analysis, we had two students, one graduate in master student, one graduate in 2019, and another win graduate in this year. We had many undergraduates, and we do one project and got three paper to the international conference, and one is a domestic conference. Yes. And now we know how to use the machine learning and deep learning approach for the sentiment analysis. And I will give the conclusion about this topic. And you know that this is a very fascinating problem. However, it's hard in the LNT. By the non-Chomsky, you do not get discovery in the science by taking huge amount of data, throw them into a computer, and doing statistical analysis of them. That's not the way you understand things. You have to have a theoretical insight. Some reference in my presentation. Uh, 1, 2, 3, 4. Okay. And the last slide, I will introduce about the RAI conference, the sixth international conference on research in intelligence and computing in engineering. This is organized in my university. You can check in this link with the topic related to AI, machine learning, deep learning for LNT, signal processing, network communication, VLSI, and embedding computing, IoT ecosystem and application. The RICE 2021 proceeding will be published in the lecture note in electrical engineering. Thank you for your attention. Yes, and now I'm here for your question.
Thank you, sir. I
Yeah.
request all the participants, if you have any query, please type it in the chat box. Now I'd like to call Ms. Alpna Meena ma'am to ask question which is posted by participant in the chat box. Ma'am,
Yes.
please, over to you, ma'am. Alpna ma'am.
Sorry.
Alpana ma'am.
Okay, I see there are a lot of questions here. Wait me.
Yeah, sir. So first question is
Yes.
how we may use machine learning and deep learning to predict the behavior tendency of human beings on social media platforms.
I think I just saw two example, and you know that how to use machine learning and deep learning for social analysis. And sentiment analysis is one approach for the social analysis. You can use another for the social analysis. It's related to natural language processing. There are a lot of that in natural language processing. No, in the before. Wait me. Okay.
Yeah, thank you, sir.
Yeah.
The next question is how we decide number of channels in CNN for any problem.
Yes, CNN. I just saw how to use CNN here. Maybe you meet this line. Let me. CNN for the fact if you want to use CNN, you have to use work embedding for CNN. Here is the example how to use CNN. Yeah,
Yeah.
and we have the sentence here, and the sentence we can tokenize the sentence to the work, and each work we have the work embedding, and from work embedding we can put in the CNN model. Yeah, to extract picture and classify.
Yeah. Thank you, sir.
Okay. Another question is
So I think no more question.
yeah, I see some question here. Wait.
Okay, sir.
Yeah. Sahida Khan, he asked me that is machine learning approach in the bad as compared to lexical approach in most way. You know that here, okay, I have this slide. Yes. Uh, Here is how to use lexical and machine learning for sentiment analysis. And you know that is the lexical way, it means that not automatically. And maybe you have need more knowledge about linguistics for the sentiment analysis problem. That's why machine learning is very famous. It means that if you use a lexical way, you may be will be expert in the linguistic, and if you hire the expert in linguistic, it's more expensive than in the computer. Yes, that's my question. That's my answer for this question. Okay, another question is Shukla. He said that how we may use machine learning and deep learning to predict behavior tendency of human beings and social media platform. Oh, okay, yes. Depend on data you collection And you can apply the machine learning and deep learning approach for this problem, for your problem. Okay. Okay, that's only two questions here.
Yes, sir.
Okay. Yes.
Thank you, sir.
Thank
On
you
behalf
for
of
the
IST
attention.
IIP IMR, on behalf of IST IIP
Hello.
IMR and the entire supporting organizing team, I would like to invite Dr. Keshav Patidar sir, Principal IST for photo openings. Sir, please, Keshav Patidar sir, over to you.
Good afternoon, all of you. It is my pleasure to be part of this webinar with you all and listen sessions of both the speakers on sentiment analysis using machine learning and deep learning.
Mhm.
I found both the sessions very interesting and very useful. I'm sure that all the participants must have benefited a lot by attending this webinar. It is my privilege to have been asked to propose a vote of thanks on this occasion. On behalf of Indore Institute of Science and Technology and the entire fraternity of the college, I extend my most sincere thanks to Sri Arun S. Bhatnagar, Sir, Director General, IST, IIP, IMR for providing guidance and full support for conduction of this event and for the informative session.
Okay, thank you very much. Yeah.
Most important, my sincere thanks to our guest speaker, Dr. Huy Thang Hung, Director, Data Analysis and Artificial Intelligence Lab from Thu Dau Mot University, Vietnam, for accepting our invitation for webinar and enlighten us on such important topic.
Uh-huh.
And
And
I heartily
yeah, if you have any question, you can check from the my page here, and you can check the contact here. Okay.
I heartily thank to all the participants from various academic institutes, and also I want to thank all the participating students.
Yes.
Finally, a big thanks to each member of organizing committee, especially Prashant sir and Puneet sir,
Yes.
for their
Thank you
sincere
for
efforts to make this webinar successful. Thank you all. Thank you.
thank you for everyone. Yes. Okay.
Thank you so much, sir.
Thank you.
Hello.
Hello.
Yes, sir.
Yeah, Bhui sir, Prashant here.
Yes. I'm here.
Sir, it is very much valuable presentation for all the dignitaries here and the
Mhm.
faculty members. And we want one of another webinar for the student also, because it is very much useful for the student of